As you can see, the title of this is More Common Ion Effect. We're going to do a couple of examples. You don't have a sheet for this, so you will have to copy it from this video. So this time we're not asking you for solubility, we're just asking you for concentration of a given ion. So right here we see it says KOH, and then we have Fe2+. Well, that's a positive ion, and it's going to be getting together with the hydroxide. So when it says the KSP, it's talking about Fe, yikes, that's supposed to be a bracket, my goodness. Anyways, we're talking about the KSP of FeOH2. So what we're saying is we're going to already have 0.050 big M of hydroxide. And we're going to be solving for the ion concentration. So we're told we have this, and in fact we can see this would break down to X and 2X. So by finding the concentration of Fe2+, we'd actually be finding the solubility of this salt in this concentration of KOH. Well, we know the 0.050 is going to go in there, and it's going to be squared, and we're going to have that being our X. So our Fe2+ equals our KSP divided by the OH minus squared. We substitute in our numbers. And we get 2.0 times 10 to the minus 14, big M. So again, this is common ion effect because we had the hydroxide already present in our equilibrium of FeOH2. Next example. So we look at this and we say, hey, we got Ag+, it's a positive ion, so it's got to get together with the carbonate. And we already are going to have a certain concentration, 0.020 M of the carbonate. So that's the equilibrium. We're given a KSP for the Ag2CO3. And what we have to keep in mind is we know what our carbonate is. And if we find the value of X, that'd be the solubility. But in fact, we know the silver concentration will be twice the solubility. So here's our KSP expression. Ag+ is squared times the carbonate equals 8.5 times 10 to the minus 12. So we've got to isolate the Ag+. And we see that's going to be the KSP divided by the carbonate. But remember, that's squared. So we're going to do this, divide it by that, and then we have to take the square root at the end. So we take the square root, we get 2.1 times 10 to the minus 5 big M. If it asks you for the solubility, we just divide that by 2, because this would be 2x, and solubility would be the value of x. So I'm hoping those examples are going to help steer you through other types of common ion effect questions.